Our next identities are the half-angle identities. So we have three of them here, and you'll notice that we have these plus minuses on the sine and cosine. And the choice of plus or minus depends on the quadrant that a over 2 lies in. So we'll talk more about that when we get to it. But question number 1 wants us to find the sine of x over 2, given that cosine of x is equal to negative 5 over 8. And x is in quadrant 2. So I'm going to draw my triangle in quadrant 2, and I know my adjacent is 5 and my hypotenuse is 8 because cosine is equal to adjacent over hypotenuse. Now my hypotenuse is never negative, and I know going to the left for x's is negative. And if you use the Pythagorean theorem, you can find that this is square root of 39. So that's by Pythagorean theorem. Okay, so we need to kind of figure out that plus minus for the identity. And we know that x is in quadrant 2, which means that it's between 90 and 180. But I want to know about what x over 2. So I'm going to divide x by 2, and that means I need to divide all the other ones by 2. So x over 2 is between 45 and 90. Therefore, x over 2 is in quadrant 1. So sine is positive in quadrant 1. So I'm going to take sine of x over 2 and set it equal to the positive version of this. And it's 1 minus cosine of x over 2. So this is equal to, and if it's plus, you don't need to write the plus because it's implied. This will be 1 minus cosine of x. I'm referring to my triangle now. It is negative 5 over 8, although we already knew that from what they gave us here. But it may not always be just the values that they give us. We may need to refer to the triangle. And this is all over 2. So this is equal to square root of 1 plus 5 over 8 over 2, which is square root of 13 over 8. If you add 1, which is 8 over 8, to 5 over 8, you get 13 over 8 divided by 2. And then you just, whenever you have a fraction divided by a number, it really just multiplies the denominator by that number. So 13 over 8 over 2 is 13 over 16, because 8 times 2 is 16. If you want to multiply by the reciprocal, because this is technically a 2 over 1, and then flip it to be 1 over 2, you can show it that way too. But this will be square root of 13 over 4. So I can actually take the square root of 16 and get 4.